Hey guys, and welcome to the solution video for the November coding challenge. Let's quickly go through the problem first. So imagine that these have strings here. Let's zoom in just a tad. Imagine these represent the first, second, and third row of your keyboard. You're then given a list of strings, like so, and your task is basically to say, for each of these strings, which one can you make just using a single row of a keyboard. So say, for example, I take Dad here. You can make this one because it has D, A, D. That's just using a single row of the keyboard here. You can also make, I think, Alaska. Yeah, we've got A, L, A, S, K, A. Yeah, that's fine. But say you take hello. We then do, let's see, H and then E from this one. So this guy is actually going to be using this row and at least this row here. So yeah, not good. So no for this. But actually you can make Alaska and you can make Dad. I think Peace, I don't think you can make. That's got P, E, A. Yeah, so that's using at least two rows as well. So your task is, given a list of strings like so, which one can you make just given this here? Just some assumptions. The cases don't matter in this case. It doesn't matter if it's big A or small a, that's fine. And let's go to our first solution. So if I bring this down here for a second. Our first one is from Ross K. Graham. I'll quickly run your code. And yeah, that looks good. We get Alaska and Dad returned. And this is really cool because we're using effectively what looks like a little sort of nested list comprehensions. If I kind of do this, and then this here, and then let's move this back, sorry. There we go. There you go. I can see why I did this on multiple lines now. So we've got word for word in words. Okay, this guy here. So you're basically iterating through this here. For keyboard row in keyboard rows, if, and then we have this kind of big conditional here. So effectively what's happening, I think, from my point of view is we're saying go through all of these and kind of simultaneously we're going to go through all these as well. And it's actually this all bit here. So the all function is going to say return true. So this entire function will return true if this condition is also true here. So it wants everything inside this to be true. So imagine this was a list containing true, true, false. It's going to be false because it needs true, true, true. So this bit, I think, is the meat of it here, really. So it's saying letter.lower in keyboard row for letter in word. Okay, seems like a mouthful, but that's really smart. So letter.lower in keyboard row. Okay, so this bit is the actual check. So letter in keyboard row for letter in word. Right, okay, so for each of this, your first lowercase thing, say if I take the H here, is saying lowercase h in keyboard row. So basically it's saying like check all of this, check all of this, check all of this. So I envision what you kind of have is like, it might be like true, true, false, 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 true. And it's basically looking for those strings where it's going to be all true, true, true. So for Dad, for example, as it's scanning through this one here, it's going to be true, true, true. So therefore this whole thing returns true. So basically what that means is we keep that word. So this is really neat, super functional, a super smart way of doing things. And yeah, I think this is genius. This is really, really well done. So just to kind of summarize this is effectively saying, go through each of these, do a check to basically say, are you on a particular row? And then for all of these things here, so say if I take all of these little three characters, this is going to be true, true, true for, in this case, this guy. So therefore we include it in the final list and therefore return that entire list. So yeah, Ross K. Graham, that is a fantastic effort. Well done. Next one is from Dan Murphy, so thanks for emailing this one over. I really appreciate it. And you've done quite a cool extension to this one. You've done this additional parameter called good characters. And this is, I think you were passing in this guy here. So first thing I'm going to do is just run your code. Let's see. Nice, yeah, we got Dad and Alaska, that's cool. So you've basically added the ability to check a specific row, which is nice. I think that's a really nice extension to do it. And in my view, you've been kind of really functional and kind of really clever with how you've done this check. It's a little bit similar to this here in terms of its logic. But of course, you've done things like, let's see, filter and map rather than like explicit for loops. Whereas this one here is sort of acting like our filter. And, you know, the kind of double for loop is acting as our map. You've kind of just gone and said, okay, here's map, here's filter, here's how I'm going to map over all of the stuff. I'm going to use filter to say, okay, for all of the stuff we're iterating over, only keep them if they match this condition. So, to kind of pull this apart a little bit, filter always has, if I just do func and sequence here, filter always has this kind of context. So the first thing you've got is a function up front. So your function is, if I can get this to the right place, that is your function here. So it's all map. So again, you've used all, similar to this guy here, which is cool. And then we're saying map character, character in good characters. So actually, this is the same basically as this here. So rather than just doing like a explicit check, you've used a lambda to do the check, which is really cool. And then word just kind of, is this, then this, then this, then this. And you've done that for each individual word. That's really cool. I think functionally, yeah, this is the same as the previous solution, but I really, really enjoy this really clever use of lambda, map, all, filter, and list. Yeah, that's brilliant. Yes, excellent job on that one. As someone who kind of enjoys a lot of functional code, this is highly functional. This is really, really good. So well done. To close off the video, I want to show you a really kind of simple, kind of as easy as possible approach to solving this problem. So I'm going to do it outside the function. I want to do it using an imperative approach. So kind of simple, boiled down, simple if statements, for loops, whatever. I'm going to try and avoid using kind of any kind of super complex built-in function. Now, the first thing I want to do is, if you imagine the problem, we basically have to say, for this word, we need to scan this, this, and this. For this, we must scan da-da-da, so on and so forth. That's going to require a nested for loop. One to go through this, and the second one to say, okay, now whilst on this, go and look at all of these things here. So in terms of time complexity, imagine this is of size n, this is of size m. You've got to kind of consider that n times m complexity. So a bit tricky, and if these were massive lists, could be potentially quite troublesome if they're really long words. But in this case, small words, only 3 rows, it's fine. So I can do for word in words, so saying, yeah, for each of these. Now let's consider for each row. So we'll say now for each row in rows. And just kind of show you where we're at, let's just do print word, and we'll also print row at the same time. No, not like that. Clear like this. And yeah, there we go. Okay, so whilst on the word hello, we're looking at this row, and this row. Okay, all looks good. Now what I'm going to do is I'm going to do a simple comprehension here, and I'm going to kind of try and step through it as slowly as I can. So mainly imperative, I guess, but yeah, I'm going to try and get a way of doing this here. So let's just say our result is equal to the following list here. So I'm going to say, let's do letter for letter in word, okay? So envision at this point, word is just hello, 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 Alaska, 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 so on and so forth. Letter for letter in word is just going to be like H-E-L-L-O, okay? So letter for letter in word. But what we're going to do here is do letter in row. So the kind of action at the front of our comprehension is going to be a true or a false. The only thing we've got to do is just do word.lower at the back here. So I think what we'll do, let's just do, we'll print result, we'll print the row, we'll print the word, okay? Just so you can sort of see what's going on. We'll look for a few trues and then go from there. So we know one that is true. It's going to be on dad here. So I think it's this one. Yeah, there we go. So we get true, true, true for this row, for this word. So dad contains DAD, DAD, there they are. And effectively, that's kind of the bulk of the problem here. So whilst considering each word in each row, go and tell me if all of the characters from this word appear in a single row. So you've got a lot of true and falses here. Now what we can do is, if you envision one that did work, so true, 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 the all function will return true if given this, because all of its contents are true. So if you do all around this now, go one step at a time. There we go. So loads of falses, and we get true for this one for Alaska. False, false again. True for this one. Now if you envision, say for example, let's see one that returned true. So when we did dad for this row here, it returned true. There's no point doing a check on the second row because it's already returned true here. So if you envision a load of words return true for the first row, no point checking these two. There's a wasted checks. So we could say, if result, we will do break here, like that. But first of all, we want to basically do, let's see, maybe we'll do these as keepers. These are ones to keep. So if the result happened to be true, keepers dot append, and then go and take on, in this case, word. I had to think about that for a second. But yeah, let's try and run that, and we'll see if it works. Okay, no errors. And yeah, so far so good. Let's make ourselves a bit of space, and then we'll do print keepers like this here. So we should get the same two. And we do, Alaska and Dad. Let's make this kind of wrong. Let's do Alaska. What's the one that isn't on that row? Do Z here. This should work. Yeah, there we go. Reverse that. And there we are. So, real briefly, let's say, here's an empty list. This is going to be keeping all of the things which match. For each word, let's now scan over each keyboard row. And then here, this is going to say, check to see that, each character in our word is in this. If it is, this is going to be true. If that was true, stick the word into the keepers list and stop doing any remaining row checks for the rest of that word. Once done, no problem at all, print them out. So yeah, nowhere near as fancy as the other two, but this is, I guess, a more simple, kind of boiled down approach. Make sure you guys keep up to date with the channel. I'll be releasing the December question probably over the course of this week, and I'll try and make it Christmas themed. And of course, feel free to send me in your submissions, and once again, thanks for sending in your code. I appreciate going through them, looking at your kind of solutions. They're inspiring, they're really cool, they're really nice and technical, so again, much appreciated, guys. Have a great rest of the week, and I'll see you all in the next video.